Hi, my name is Qijun. I'm a rising senior at George Washington High School. This is my final milestone, and in this milestone I have finished creating my chassis for my robot and also complete programming with OpenCV libraries. So that means now I have an object tracking robot that can recognize an object and automatically follows it. So once I run the program, my robot keeps rotating right until it sees this ball and stops when the ball is 20 centimeters away from it. But if the ball is outside the range of the center range of the camera vision, it automatically adjusts its position along its path and rotates left and right to make sure that the ball is always within the center range of the camera vision. So before working with OpenCV, I need to design a chassis for my robot. So what I did was I measured all the sizes of the individual components that my robot uses, and then I created a design for my robot. So this is the top part for my chassis. There's a power bank, a Raspberry Pi, a breadboard, and the H-bridge motor driver, and two ultrasonic sensors, one in the front and one in the back. And then later on, I add on another one on the left. And this is the bottom part for my chassis design. There's a caster wheel in the front that can go in any direction, and there are two DC motors that are connected to the chassis with the L-shaped bracket. So then I work with the OpenCV libraries to run a program to let my object recognize the largest red blob appear in the camera. So the way that my object works is that it uses the Raspberry Pi camera, and then I set the resolution to 120 by 160 and the frame rate to 60. Then it analyzes each frame rate coming into the Raspberry Pi camera, and then it uses two different color spaces so that external lights does not have a significant effect on the frame rate that it takes. And one of the most significant challenges I had was that my robot would move forward even if it sees any objects in orange or yellow. And after debugging and researching, I realized that the HSV color I used before, which is a color system that focuses on separating the different variation on one particular color, is ineffective when external light comes into play. So I added in the YCRCB color space, which is robust against external changes, and then I combined the two color spaces and converted the frame rate to grayscale so that my robot can draw a square around the largest contour of red blob appear in the camera, and also to avoid unnecessary details in the camera. Another challenge I faced was that my robot did not move into a straight line, and the reason for that was that the two motors do not spin at the same rate. So the right motor spin a lot faster than the left motor, and what I did was I changed the PWM output value, which stands for pulse width modulation. And what it does is basically it controls the amount of voltage being sent to the motors, and I adjust the PWM value for the right motors to 80%, which means the right motor will spin at a rate that is 80% of its original rate. And now those two motors spin at the same rate, and they can go in a straight line. So before coming into BlueStamp, the only engineering-related project I had worked on was programming in Snap and Python. But throughout the 6 weeks in BlueStamp, I have developed an interest and passion in electrical engineering and software engineering. And I also learned fundamental drilling, sewing, and soldering skills. In the future, I will keep modifying my robot by adding in more features such as machine learning to make it more reliable. And I will participate in more engineering programs and work on more intensive projects that require a combination of hardware and software. Thank you.